Hello friends, welcome to Dr. Acharya Academy. Today we'll discuss about the chemistry class 11 from the CBSE syllabus. It is the unit number 8. The topic is redox reactions, electron transfer reactions. Today's class ID 202. So we'll start with examples of the redox reaction, what we already discussed in the previous class number 201. This is the reactions. Sodium react with the chlorine gas to form the sodium chloride. Again, sodium react with the oxygen gas to form the sodium oxide. And another reaction is sodium react with the sulfur to form the sodium sulfide. These all are redox reaction we understood from the previous class number 201. Now, on these reactions, the sodium is oxidized. The sodium is oxidized because it is attached to the either oxygen or other electron negative elements. Just for example, chlorine and sulfur. Chlorine, oxygen, sulfur are reduced. These all are reduced because it is attached to the electropositive element sodium. That's why in each reaction, both oxidation and reduction is happening. So that's why it is called the redox reaction, what I understood from the previous class number 201. Now, from our knowledge of chemical bonding, we know that the sodium chloride, sodium oxide, and sodium sulfide are ionic compounds. So how do we write this? We'll write the ionic forms of the sodium compounds is Na plus Cl minus. For sodium oxide, Na plus whole twice subscript and O2 minus. And this is also in solid form. Another sodium sulfide, Na plus subscript 2 and S2 minus. It is also in solid form. So in this way, we have seen that how to write the compounds in its ionic form. So now we have seen that charge of each element it is there. So development of charge on the species produced suggests that to rewrite the reaction in the following manner. So same reaction, if you see the 2Na plus Cl2 will form the 2NaCl. Now it is in ionic form, the product is Na plus Cl minus. So now we can see that the 2Na, that means 2 atoms of sodium, it will lose total 2 electrons to form the 2Na plus. Cl2, this gas consists of the 2 atoms of chlorine. So each atom of chlorine gains 1 electron to form the Cl minus. So the 2 Cl atoms in Cl2 gas will gain the total 2 electrons to form the 2 Cl minus ions. In the same way, for the sodium, again it lost the total 2 electrons to form the Na plus 2, and oxygen O2 will gain total 2 electrons to form the O2 minus ions. In the third case, for sodium 2Na, sodium will lost total 2 electrons to form the Na plus whole twice. and the sulfur will gain 2 electrons to form that S2 minus. So here you can find that for the one element the loss of electrons and another element is the gain for the electrons. So if we take the first example, that means 2Na plus Cl2 is 2Na plus Cl minus. In this case, we clearly now know the loss of electrons happening for the sodium and gain of electrons is for the Cl2 gas to form the product Na plus Cl minus. So this total reaction process consists of the two separate steps. First step is that 2Na in solid form, it will form the 2Na plus in gas form, plus it will release 2 electrons. And these electrons will absorb by the Cl2 gas to form the 2Cl minus in the gaseous form. So these total reactions consist of these two steps. Each of the above steps, this step 1, step 2, each one is called the half reaction, which shows the involvement of electrons. In the first case, the release of the electrons, and the second case, gain of the electrons. So sum of the two half reactions, these two half reactions, if we sum, then you can see the left side 2 electrons and right side 2 electrons, it will cut, and ultimately the overall reaction will be 2Na plus Cl2 will form the 2NaCl. And now the half reaction that involves the loss of electrons is called the oxidation reactions, and similarly the other half, that means which gain the electrons, is called the reduction reaction. That means for the step 1 where the loss of electrons is happening, this is called the oxidation reactions, and then second step where the gain of the electrons happen, it is called the reduction reactions. Now we find the new way of defining the oxidation and reduction by establishing a correlation between the behavior of the species as per the classical idea, which we discussed in the class number 0201, and their interplay with the electron transfer change. Just now, whatever we understood. So again, if we consider the reactions with the loss and gain of the electrons, then we find in this case, in these all reactions, the sodium which is oxidized, that means the loss of the electrons. It is the oxidized and it will act as a reducing agent. That means it will help the other elements. That means here the chlorine, oxygen and sulfur to reduce. So that's why the sodium is oxidized, and so it helps to other for the reduction. So it is act as a reducing agent because it donates the electron to each of the elements, that means chlorine, oxygen and sulfur, interacting with it, and this thus helps in reducing them. In case of the chlorine, oxygen and sulfur, what is happening? These are reduced after gaining the electrons, that means after accepting the electrons, and it helps to oxidize the sodium to get the sodium plus ion. That's why it is called the oxidizing agents. So now if we summarize this, then we'll see what is the oxidation. Oxidation means loss of electrons by any species, and reduction is the gain of electrons by any species. And oxidizing agent is the acceptor of electrons, and reducing agents donor of the electrons. From the previous understandings, we came to know these four things: what is oxidation, what is reduction, what is oxidizing agent, and what is the reducing agent. Now we'll see one example, very simple example, that the 2Na plus H2 will form 2NaH. So we have to justify this following reaction is a redox change. That means both reduction and oxidation happening in this reaction. So solution. In the above reaction, if you see, then the compound is formed, that means NaH formed, which can be represented by the Na plus H minus. This one. This product can be written in its ionic form Na plus H minus. So, what will be the first half reaction? First half reaction is that this 2Na in solid form will form the 2Na plus in gaseous form plus 2 electrons. What is the second half reaction for this hydrogen gas H2? So for the H2 in gaseous form, it will accept these electrons, 2 electrons, to form the 2H minus. So if you add these two half reactions, ultimately you will get these reactions. 2Na plus H2 will form the 2NaH. So this splitting of reaction, what will show? These half reactions reveals that the sodium is oxidized because sodium is donating electrons. So it gets oxidized, and for hydrogen, it is accepting electrons. So it is getting reduced. So therefore, the complete reaction, whatever the reaction is given in this problem, 2Na plus H2, product is the 2NaH, this is a complete redox change. So in this way, if other reaction will come, we can solve in the same way. I think that you understood a very clear way the electronic transfer reaction for the redox reaction and the definition of the oxidation, reduction, reducing agent, oxidizing agent.